So name this function f of x and try to find preferably a 1-unit interval where a solution exists. It's a continuous function, right, on all its domain. Of course, I see that I cannot plug in anything to the left of -1 because x plus 1 has to be greater than 0. These are no problem. So from the square root, I know that x plus 1 must be greater than or equal to 0, so x greater than or equal to -1. So the domain of the function f is -1 to infinity. So don't even attempt to plug in anything to the left of -1. It's not going to work. And so once I find that 1 unit, I don't know how many solutions the equation has. I only want to determine one for now. And I need to find a 1-unit interval in which there is a change of sign because it's a continuous function on this domain. And I'm quoting the intermediate value theorem, right? We remember the intermediate value theorem? Okay, the function is continuous, and one end of the interval is either positive or negative, and the other one the opposite sign, so it must change sign. Savannah already did the work for us, and she said
1 to 2.
1 to 2. So she did that. She did the work for us already. She plugged in 1 in the function. She plugged in 2 in the function, and it appears that the function changes sign somewhere between 1 and 2. Good. Now we have to write Newton's method, and here it is. We will create a function. I'm going to call it Newton, which is x minus f of x divided by f prime of x. I will put in the function we have, which is the square root of x plus 1 minus x squared plus x. I will determine its derivative, 1 over 2, the square root of x plus 1 minus 2x plus 1. I'm going to put this function as is. No simplifications, nothing. But very carefully put it in the graphing calculator. And then you will have to tell me which point do you want to start with. You want to start with the left end point of the interval, which is 1, or you want to start with the right end point of the interval, which is 2. Remember the 2 cautions, 2 warnings. Warning number 1, if this function is undefined at 1 or 2, we're in trouble. Well, it's not undefined at 1. Because this is the square root of 1 over 2 the square root, and this is -1. So at 1 is definitely not undefined. Let me try it at 2. No. So we are safe. The second condition, that's why I suggest a 1-unit interval. Can a function have a maximum between the solution and 1? Yeah, but quite unlikely. If we stay with a 1-unit interval, we're most probably safe. There is no max or min in between the actual solution and our starting point, either 1 or 2. But if there is, the method will not converge. We're going around in circles and we will not get anything. How do I know I don't get anything? One solution is 2.5, the other solution is -3, the next solution is 2.5, the other one is -2.3. Stuff like that happens without seeing that the solution gets closer and closer to a number. Then I know I'm not on the right track. So what is our x0? We have to decide. We pick. It doesn't matter which one you want to pick. I checked. F prime is defined in both. You want to start with 1 or you want to start with 2? Okay, 1 is good. Okay, so let's put the function in. Here it is in y equals. Be very careful. Minus. Parentheses for the top, the square root of x plus 1. I will definitely put parentheses around x plus 1 because you know me. Your calculators are more sophisticated than I am. So maybe, but be very careful. Minus x squared and plus x. Close the parenthesis for the top. So notice I put parentheses under the square root, and I have parentheses around the numerator. Now divided by. Parentheses around the denominator. So now I have to put that 1 over 2, blah, blah, blah. So careful how you put that in. I will put it like this. 1 divided by 2 further divided by, sorry, that's not what I meant, further divided by the square root of x plus 1. This is one way. But of course, I will put parentheses inside x plus 1, inside the square root plus 1. Close the parenthesis. And then go outside. So what does this mean? It says 1, for the calculator will divide 1 by 2, and the answer will be further divided by this. Or you need parentheses around 2 and the square root, and this has to be changed into multiplication. It's up to you. I wanted to avoid an extra set of parentheses. So you can put parentheses here, multiplied by this, but another parenthesis here. So be very careful how you put it in. Okay, so minus 2x outside, not under the square root, and then plus 1, and close. So one more time, this is 1 over 2, and further divided by the square root minus 2x plus 1. So this is the function that I called Newton that will give us every iteration, one after the other. Ready? So now we go second and quit. Go to variables. I put in my variable in y, the function in y1. So go to variables and then select function. It's already selected. Say enter. And enter again for calling function y1 that we just finished, the Newton function. And now in parentheses, we decided to start with 1. So then in parentheses, I have 1. And I would like you to tell me what this is. Kind of weird, right? Because I'm expecting a solution between 1 and 2. Okay, we have not concluded anything yet. Okay, so let's go back. We have to copy this down as x1. Okay, in a minute. So I go back with second and entry. So I recall this with second and entry, and overwrite 1 by the, by the previous answer. So go over 1, second and answer, and press enter. We are getting there. Okay, then second and entry. Don't do anything else, just press enter again. Good, we are on the right track. Second and entry. We have not established how many decimal digits. Where do we stop? How many we want to see repeating, and then we say this is it. We cannot determine a perfect number, right? It's an irrational number. We can never be able to finish. But we have to make a decision. 3, yes? Right, yeah. So 3, 4. I mean, you can go on forever, but let's stop somewhere. Where do we want to stop? 3? Is 3 okay? Okay. So I see 8, 9, 7, 6, 7. Okay, I'll do this again. Press enter, and I'm done. So 8, 9, 7, repeat. So I would say this is, what was it? 1, so x1, x2, x3, x4. In 4 steps with 3 decimal digits, the method converged, meaning we found the answer. That's what we mean. So the answer is, because we want to stop at 3, it's 1.897. If you want to continue, you will say just 897 because it drops to 1. So the problem that I would like you to solve on the test or final exam, I would like you to list x0, whatever you pick. Then list x1, 3.1876726. Then list x2, 2.22. Except to 2.2273933, x3 1.9322877, x4 1.89767, and you do not have to list x5. It's 1.8971. So you will say, I'm happy with this as the solution. 1.897, because we decided to use 3 decimal digits. Yes. Right?
Since it's a solution between 1 and 2, could it have been 1.93?
Yes, it could have been anything between 1 and 2.
So any of these solutions work? Or
We
only
wouldn't, but we want accuracy with 3 digits, where we have to wait till they repeat. If we want 3, of course, this is a much worse solution than this one. This is closer to the real solution. And this is closer to the real solution. And the next one will be closer. And the next one will be closer. Because more digits will repeat. So this is good, but it's not good enough. Because we decided 3 decimal digits have to repeat. So they are repeating in the next one. I don't care for this one anymore, so I will say 1.897. As long as 3 digits repeat. If I want 4 digits, then I would have to go to the next step. So the solution would be considered 1.897 because we only wanted 3 digits accuracy. Is the method clear? But we have to remember what? Number 1, we have to remember Newton's method, right? The x minus the function over its derivative. Then we have to remember to put in the graphing calculator and how do we do the iteration process, okay? Step 1, step 2, step 3, and we have to look at how many decimal digits accuracy we are asked to use. Yes?
So the x minus f of x over the derivative of x, that's like the formula.
That is the formula.
Okay.
Yes, that is the formula. Good. Anything else? Any questions for me? Anything? Yes, Ricky, go ahead.
How did you find 1, 2?
Oh, we found 1, 2 by entering in y equals. Savannah helped me tremendously because I didn't have to start from scratch. So our function is this. This is what we did in chapter 1 with the intermediate value theorem. So this was our function. And if you go to second and table, sorry, I have to adjust this again. If you go to second and table and you plug in 1, and then plug in 2, you will see the sign change. And by the intermediate value theorem, the function has to have a 0 between 1 and 2. Is that okay? Perfect. Anything else? Okay, so let's finish. So on Tuesday, I would like to review this material, for test 3. Everything we studied in chapter 4. So I will bring you our test and we're going to work on it on Tuesday. So I would like to take this test on Thursday next week if possible. If not, we'll decide to take it outside of class somehow. We'll see. Because we have to start chapter 5. Any questions? Any questions about homework? Did you have? Yes, Savannah. It's in the video. It's in the lecture notes. It's in the lecture notes.
Okay.
Yeah. When you go back, I'll show you. Okay. So if you don't want to turn in homework today, you must turn it in on Tuesday. Okay. So any questions from you before we look at the last section? Optimization. Okay. This is 4.8. No, this is 4.7. So, sorry, 4.7. We did 4.8, which is Newton's method. Yes, this is 4.7. We do not cover 4.9 before test 3. 4.9 will be together with chapter 5 in test 4. We're not going to skip 4.9. It's absolutely required before chapter 5, but I'm going to connect it to chapter 5. Yes.
So 4.9 would not be on this test?
No, we'll be on the next test.
Oh, okay.
Yes, we'll be on the next test. Very good. So optimization. Should I move him from there? Is he going to stop talking? Good. Okay, thanks. So optimization, like algebra, trig, geometry, calculus, differential equations, and you name it. This is a huge branch of math. Huge. It deals with finding max-min of different functions, optimizing a function, in other words. It's a very huge topic, and it's not a topic, it's just a big branch of math. So we're going to just look at the little slides, tiny slides. Of course, optimization can be dealt with more than one variable. Here, of course, in Calc 1, we're only going to look at one variable. Functions that are functions of one variable. So let's see how we work on these. Everything is known, we just have to practice. So what is the idea? Read the problem carefully. Make sure you understand what is given. Make sure you understand what is asked. Make sure you find a function that you will find the max or min for. That's all. One more time. We read it carefully, exactly what we did at related rates. The same idea. We read the problem several times. We take notes on what is given. We understand what we are asked to determine. We create a function that we find the max or min for. Just more word problems. Okay, on page 332. Let's start with problem 14, and then you choose the next. 14 on 332. Should I write those steps one more time for everyone, or are the steps clear? I should write them down. Very good. Okay, number one, read the problem. Read carefully. We may need to read it more than once. That's step number one. Step number two, take notes and understand what is given. Take notes. Make sure you understand what is given. What is given and asked to determine. Number three, create a function. Number four, find its max or min, depending on what we are asked, and do not forget to show that indeed it is max or min. I have to show why it is max or min. I have to study the sign of the derivative, of course. So I create a function. Of course, I'll find the derivative, the critical numbers, of course, and I'll find its max min, and I have to show that that is indeed a max or a min. I cannot just say I found the critical number, this is it. I have to show that that critical number turns into either max or min. So this is the idea. Read carefully, take notes, understand what it is given, what is it asked, create a function that helps us find the maximum or minimum of what we are asked to do or find. Okay, so problem 14 on page 332. Yes, Ricky, go ahead.
So number 4 is like create a
Yes, I have to create the table, but only for the derivative and the function. We're not graphing, so we don't need the second derivative. Very good. Okay, so let's read the problem together. Here it is. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. So that's our first problem. So let me write this one more time. 32. So we have a box with a square base. Okay. This is a box with a square base. This is what the first line tells me. A box with a square base, XXX, and some height. It says it's an open top, so it doesn't have a lid. Must have a volume of 32,000 cubic centimeters. 32,000 cubic centimeters. Find the dimensions of the box. Such that the amount of material used is minimum. minimum material dose. Okay, one more time. We have a box without a lid, open top. It has a square base. It has some height. I have no idea. I know it has to have this volume. And I'm asked to find x and y, x and h, such that the material that I use, and it has that volume that's fixed, the material that I use to create the box, to build the box, is the minimum possible. So then, first of all, I'm asking myself, what type of function am I looking for that I need to minimize when we talk about surface or material, the area? Very good. That's the first idea that has to come to our minds immediately. Area must be minimized. Good. Can anyone give us the area of this box without the top? There is no lid.
Is it sphere?
Say it again.
Is it sphere or rectangle?
So only the base is a square.
Area time, left time, left.
Good. So
2.
exactly, x squared plus 4xh. Very good. It has 4 sides that are rectangles, base times height, 4, they're the same, 4 times x times h, plus the base that is x squared. So this is now a function, but I cannot say that it's a function of a variable yet. I need to make it as a function of a variable, but I have an information that I haven't used yet. Can anyone give us the volume of this box? Very good. X squared times h, base times height, area of the base times the height, which is 32,000. Good. What do you think I'm going to do with this? Because I need a function of one variable. I need one variable here. Exactly. Thank you very much. 32,000 divided by x squared. Once I plug it back in, then I can say that the area is a function of one variable, which I could not say before. So this is x squared plus 4x multiplied by 32,000 over x squared. Now let's stop for a moment. Do we agree with all steps? Yes, Vanessa?
You just plug it in the equation.
I cannot use two functions. I cannot have two variables in the same function. So I solved the given information for h and I plugged it back in. Are we okay? Everyone? I will simplify a little bit. So then the area is x squared plus, I'll simplify an x in the denominator. So I multiply 4 by 32,000 and I get 128,000. So let's see where we are. So we read it, we took notes, we understood what is given, we even made a picture, we have a picture. We know what it's asked, we created a function, and now we're in the last stage in which we find its maximum and also show, or minimum, and also show that it is max or min. How do we do that? So we have this function, and we want to find its minimum. What do I have to determine? Very good. So in other words, I have to find a prime first. Excellent. Well done. So I have 2x minus 128,000 over x squared. That's why I kindly asked you a long time ago to remember that 1 over x prime is
minus 1 over x.
Because it's so common, very common. So I find the least common denominator to be x squared, so this is 2x cubed minus 128,000. I have to do that because I need to solve the equation a prime being 0. So I have to combine this. So I have 2x cubed minus 128,000. And now I set this equal to 0. Can this function be undefined? Yes, it can be undefined when x is, yeah, but so is the function, so it cannot be a critical number. The function, yes. So it cannot, yes.
Where did the cube come from?
Okay, can anyone explain? We always learn a lot when we explain to other people. Can anyone explain where the x cubed came from?
Two in front, and then you do 2 points, or
You subtract, have the x squared as LCM.
Yes,
We cross multiply the common denominator.
because we cannot subtract two fractions that don't have the same denominator, right? So we have to change this into 2x cubed over x squared in order to subtract it. Is that okay, everyone? Yes? Is that clear? Perfect. Good. So the derivative cannot be undefined. It is at 0, but so is the function. So no critical numbers come from that. So when we set it equal to 0, what do I have to write? When is a fraction 0?
Let's see what it is.
Excellent. So I have 2x cubed minus 128,000 equals 0. I'll, of course, first divide by 2. So I have x cubed minus 64,000 equals 0, or x cubed equals 64,000. Yes, we expect 3 solutions. However, 2 of them would be imaginary. So there is only one real solution. And what would be the real solution? And how do I determine it? Thank you. So then x equals? Excellent. Of course, centimeters. We're also asked to find the height. I have not shown yet that x equals 40 creates a minimum surface area. I have not proved that yet. But I want to find the height because I'm asked to find both. So let's find the height, which was 32,000 over 1,600. So it turns out that the height is 20. Perfect. So now I have to go back to proving, oh, this is the area. The problem is not asking us to, it says find the dimensions of the box that minimize the amount of material used. I would like to determine this and see what the surface area would be, or the material used. I can plug 40 in the function to find this number. But I'm more interested to show that this is indeed going to give a minimum. So I have to look at the derivative. Here's the derivative, right? I will not plug in anything in the denominator. Why is that?
So it's going to be positive.
Always positive. So I only care about the numerator. And in the numerator, I will plug in 0. And what type of number do I get? Positive or negative when I plug in 0? That's it. That's all I needed to know. When I plug in 1,000, 1,000 to the third times 2 minus this will be definitely positive. And this is good enough. However, I will determine this. Any questions? Any questions? So it is very clear that this is the situation. And I showed with the sign of the derivative. Left negative, 0, and right positive is typical for a minimum. So this is the minimum material. So we can go back to the function. The function was x squared plus 120,000 divided by x. And if you want to give me, if you want to plug in, I'm going to do it with a calculator. X squared, I have x squared and plus 128,000 divided by x. And I want to plug in 40. And I got 4,800. So 4,800 is the minimum 4,800 centimeters squared. Is the minimum material used. To build this box, we do have, it does have a constraint. What is the constraint? 32,000 cubic centimeters and a square base. Yes, Vanessa?
So can you go back up? I think I have to do the is it, can you just go back? Yeah, I should use that directly for it's x squared. You plugged it into that equation.
Right, because this is the function.
Okay.
This is the derivative. I know it's 0 at 40. That's how I got 40. and this is I plug in the function. That's how I get the maximum or the minimum.
Okay.
The maximum or the minimum is given, actual value is given by the function. Where it is, it's given by the critical number.
Okay, and 40 is the critical number in this case, right?
40 is the critical number. Very good. Any questions on this problem? Do we get the idea of optimization? I know this is just one problem. Do we get the idea behind optimization? We do? Okay, good. So let's choose the next type. Yes, many of them can be quite involving. We have not looked at much at trig functions, so why not? 42. It's about time. (42) on page 333. Okay, an object with weight W is dragged along a horizontal plane by a force acting along a rope attached to the object. Fine. If the rope makes an angle theta with a plane, then the magnitude of the force is given to us. So this is a function. Where W is a constant called the coefficient of friction. For what value of theta is F smallest? In this case, for this particular problem, yes, we have to read it carefully. Yes, we have to take notes and understand what it is. But this step is already done for us. We have the function. They're giving us the function. So all we have to do is the other 3 steps out of 4, because this was given. It's good. So we'll read it one more time, and let's copy the function. Leave some room, because I think it's intentional. They're not really telling us which one is a variable. Well, they are, but they're not telling us in the function, so I don't like that. So we will make a minor adjustment. So an object with weight W, so that's the weight of the object, is dragged along blah, blah, blah. If the rope makes an angle theta with the plane, then the magnitude of the force is this, where W is a constant called the coefficient of friction. For what value of theta is F smallest? Yes, Ricky?
Is that M or is that M?
This one?
Yeah.
This one is mu.
Yeah.
So what do I put in here? It's very important to identify the variable. In this class, we cannot have more than one. Calc 1. So which one is the variable? Theta. Theta. For what value of theta is F the smallest? So W, mu are constants. W is the force. W is the weight. Mu is a constant of friction. So theta is the only variable in the problem. Is that okay? Yes? Perfect. So then, what do I do?
Do you find the derivatives?
Absolutely. So I find the derivative f prime of theta. However, I recommend differentiating this. To which power? Yes. I highly recommend changing the function into this. I meant to write the -1 here. W, mu W have to stay. They don't get power -1, only the denominator, of course, gets power -1. Good, so let's differentiate. So this is good. So this is mu W, -1 times mu sine theta plus cosine theta raised to -2 times the inner function prime. The first function, the first piece, it's not a product. This is a constant times sine. So it's mu times cosine theta minus sine theta. That's it. That's all we need. So this is minus in front. It's mu w, in parentheses, mu cosine theta minus sine theta, everything divided by mu sine theta plus cosine theta raised to which power? Excellent, well done. Okay, let's see if we need to do this again. If we need to, we'll do it again. So I changed mu w over that into mu w times the denominator to -1. So the constant, when I differentiate, the constant stays in front. I bring the power in front, and I subtract 1 from the power. But now I have to differentiate the inner function. When I differentiate this piece, I get mu cosine theta. When I differentiate this piece, I get negative sine theta. Is this okay? Yes?
We just did the, I don't know how to word this, like inner,
The chain rule.
yeah.
Correct.
I can understand that.
Yes, yes, the chain rule. Yes. So now, minus in front, mu w at the top because they have power 1. This piece has power 1, so it has to go to the top, stays at the top. And this has -2, so it goes to the bottom. What happens next? We found the derivative, so what? What now? What do I do with the derivative?
So this is 0.
Excellent. Thank you. We have to set f prime of theta equal to 0. So then what can be 0 from all this? Correct. Not mu and not w. These are constants and they cannot be 0. Just this parenthesis. So mu cosine theta minus sine theta equals 0. Okay. A long time ago, we solved the trig equation, or two. Let's do another now. So mu cosine theta equals sine theta. And we will divide both sides by sine theta. Now, every time I divide by a variable or a function with a variable, I have to worry about it being 0. But it cannot be 0 because if it is 0, if this is 0, then mu cosine theta being 0, that would be 90 degrees, right? For cosine being 0. Now, can I drag on a plane a weight to a rope with a rope if it's vertical?
No.
No, we're not really talking. We're talking about yes. So it's not going to be okay. It's not going to be 90 degrees. Secondly, whenever we solve an equation like this with sine on one side and cosine on the other, we normally divide either by sine or cosine. We normally divide by, it doesn't really matter. We can use tangent or we can use cotangent. So if you divide both sides by cosine theta, then we will get tangent. If we divide by sine theta, we'll get cotangent. It's up to you. It doesn't matter. We're going to get the same answer either way. But these two cannot be 0 at the same time. There is no angle that has sine and cosine 0 at the same time. So we're not losing a solution by dividing by one or the other. So keep that in mind. So you would like to divide both sides by cosine and get everything in terms of tangent? Okay, perfect. So when we divide this side by cosine, we get mu. When we divide this side by cosine, we get tangent. So one more time, why am I dividing both sides by one or the other? Because I can't have two trig functions in an equation. Not convenient to solve. So I want one trig function. And now I only have tangent. Yes?
3 times mu.
Mu is just a constant. 15. I don't know. It's the coefficient of friction. We don't care. They're not giving it to us. Okay, we're only trying to determine theta. Okay, how do I determine theta from this equation? What do I have to do to both sides to determine theta? Can't. Mu is just a constant. If mu bothers you, just replace it by 15, and at the end we put, instead of 15, we put back mu. I'm solving for theta. Nope. Okay, let me refer back to something else. When I solve the equation x plus 1 equals 2, what do I do to both sides? Why am I square? I want a cube. I don't want a square. It's not going to help if I cube, is it? Why? Because power 3, and what power is the square root? No. 1/2. 1/2 times 3 does not equal 1. So I'm not eliminating the square root by taking both sides to the third power. I need to take both sides, as you said, to the second power. So I'm using the inverse function. That's what I'm getting at. So now I want to solve this equation for theta. But I have it inside a function called tangent.
The inverse of tangent.
Right. We graphed it from day one. So we are applying arc, tangent to both sides. Exactly the same idea. Here, power 3 doesn't work because I have to use the inverse function of the square root. Here, in order to eliminate tangent, I have to use its inverse. Good. So then this will be arc tangent mu, which is a number. So I claim that arc tangent mu is a critical number for f prime, but I don't claim yet whether it gives a maximum or a minimum. I don't know yet. I have not shown anything yet. So the question was, for what value of theta is f smallest? I don't know. I have to study the sign. If this is negative and this is positive, it's guaranteed that arc tangent mu will give a minimum for f of theta. But if I have positive and positive, or positive and negative, or negative and negative, something is wrong. So we have to go back to the derivative. Ready? One part of the derivative I will not worry about. Which part?
Denominator.
Yes. This whole thing I don't worry about. I don't care. Right? Yes, Vanessa?
When at the top, like in front of the parentheses, why do you?
They're constants. Mu is the coefficient of friction and W is the weight. They can be 0, they can be negative. Good. So now I have to study the sign of this, but do not forget this negative in front. Ready? Okay. So let's go back to the table. Okay. So I'm going to say 0, because this cannot be 0. So let's plug in. How much is sine 0? 0. How much is cosine 0?
1.
Good. How much is mu times negative 1? A negative number. That's all I needed you to say. Now I have to go to the other side. I know that arc tangent mu cannot be more than 90 degrees. It cannot. So I'm going to try and see, not here. Let's see what happens with 90 degrees or pi over 2. Cosine pi over 2.
0.
Perfect. Sine pi over 2.
1.
With minus in front.
Negative.
With minus in front. That's all I needed to show. So therefore, this is typical for a minimum. There is no other way, because the derivative, this is the critical number. The sign of the derivative is negative positive. I don't know what it is. I can plug in arc tangent mu to determine it as much as I can, but I don't know what it is, but I don't care. I know it's guaranteed that arc tangent mu replace theta by arc tangent mu will give a minimum force. Any questions? Yes?
So what would be your final answer to this kind of question?
Arc tangent mu.
That's
Arc tangent mu theta equals arc tangent mu is the angle that gives the minimum force.
is that
Because this is the force. Oh, I didn't put parentheses. Sorry. This is the force, and it will be minimum when I replace theta by arc tangent mu.
is that considered a critical number?
Yes, it is.
Okay.
It is the critical number, it gives us 0 for the derivative, yes. Absolutely, if there is no critical number, there is no max min. Very good question. Any questions, anything else? Okay, moving on. Let's take a look at the poster. 34. A poster is to have an area of 180 squared inches with 1 inch margins at the bottom and sides and 2-inch margin at the top. What dimensions will give the largest printed area? We may need to read the problem several times. Let's come up with a little figure. Let's read it one more time and see what happens. That was 34. Page 333. Okay, so a poster is to have an area of 180 squared inch. One-inch margins at the bottom and sides. And a 2-inch margin at the top. What dimensions will give the largest printed area? We know that the total area of the poster, this is the total area, is 180 squared inches. We don't know length and width. We have no idea. So this is X, this is Y. And we know one thing for sure without even thinking. What? That X times Y is 180. We also know that the dimensions of the printed area will be X minus 2, very good, times Y minus 3. So this is the printed area. This is what we know so far. Let's regroup. Let's go back and think about it one more time. We have a poster. And we know that the area is 180 squared inches. And we know that the margins are required, for some reason, 1 inch around the printed area and at the top 2 inches. Yes, Ricky, you had a question? Okay, because from Y, we removed 2 inches and we removed 1 inch to get this length of the printed, the height of the printed area. And the width of the printed area would be just X minus 2 inches. Better, everyone? Yes? Okay. So we have a total area. We know that the margins have to be fixed for whatever reason. These are the conditions. And we want to maximize the area of the printed surface, or the printed area needs to be maximized. Is it clear how we got the printed area, the area of the printed area?
No.
We denoted this by X. Is this clear that this is X minus 2? So this is X, and I remove 1 inch, and I remove another inch, and I have X minus 2. Better? And the same thing with the Y. We have 2 at the top and 1 at the bottom. Okay, so this is the area. What are we trying to do with it? to this function. What are we trying to do? Maximize it. Very good. So this is our function. We cannot say for now a of x because it's not a of x yet. So this is xy minus 3x minus 2y plus 6. I distributed x minus 2 times y minus 3, xy minus 3x minus 2y plus 6. And I realized that I have two variables, not one. But I am also given x times y equals 180. So first of all, I will definitely replace this by 180 because it's in the problem. So a equals 186, 180 plus 6, minus 3x minus 2y, bless you. I still have not gotten rid of one of the variables. Now I'm ready to. Which variable we want to get rid of and how? Okay, perfect. We want to get rid of y, so we have an equation that will enable us to do that. How much is y from there? 180 over x. So from here, y equals 180 over x. So then a of x, finally, we have a of x. Yes?
Did you mean not to put the 6 at the end of the equation? Or
Say it again?
The 6 plus 2?
So this is, oh, I said 180 plus 6, but I didn't put it in. I said 186, but I didn't write it. Sorry. Thank you. I said 186, and I didn't write it. My apologies. So now we replace y by 180 over x. So we have 186 minus 3x minus 360 divided by x. So negative 2 times 180. Good. So we are halfway to the solution, right? We found the function. What next? 0. So let's find a prime. Negative 3 plus 360 over x squared. Again, comes back with 1 over x with minus in front this time. So it's going to be plus 1 over x squared. Is this okay so far? Yes, Vanessa?
I missed where you got
That's
the
okay.
60.
I have to replace y in here by 180 over x. Negative 2 times 180 is negative 360 over x.
Okay.
And then we differentiate, and this it goes away, and we have negative 3. But this now changes into positive because 1 over x is negative 1 over x squared with minus in front positive 1 over x squared. Of course, we have to combine like terms. Can anyone tell us what to write?
Minus 3x squared.
One of my students said yesterday that I do the little math too fast, and I said, okay. So I'm trying to slow down. The little math meaning adding. Yes, Ricky? Because when you differentiate 1 over x, you get negative 1 over x squared. Should I write that? So a long time ago, we differentiated 1 over x, and we got negative 1 over x squared. But if I have a minus in front, of course, here it will be changed into positive. And that's what we had. We had the minus in front. I differentiate this. It's 360 over x squared with minus in front, but there is a minus. That's why I have to change. I have to multiply. Okay, so let me, if there is a question, let me show that one more time. So if I have negative 360 over x, it's like negative 360 multiplied by 1 over x. And when I differentiate this, I get negative 360 times negative 1 over x squared, which becomes 360 over x squared with plus in front. Is that better? Yes? Is that better? Okay, perfect. So this is our derivative. What do we do next? We have the derivative. We have to set it equal to 0. Very good. So then a prime equals 0 means negative 3x squared plus 360 equals 0. Yes, of course, I will divide by negative 3. So I get x squared minus 120 equals 0. Or x squared equals 120. And now I want to apply the cube root to both sides. And you will say, it's not going to work. You have to apply the inverse function of this, which is not the cube root, but yes. I should write plus or minus, however, because we are talking about the width of a poster, I will not put plus or minus. I will just keep plus. And this is 4. 120 is 4 times 30. So this is 2, the square root of 30, and I think we had inches. I claim that this gives a maximum area. And you should say, show me. Your claim means nothing. You have to show me. I will determine the y, and then I'll show y to the square root of 30 gives a maximum area. Ready? So let's find the y. Remember, y was 180 over x. So 180 divided by 2, the square root of 30. Have to simplify. So this is 90 over the square root of 30. And yes, I have to rationalize by the square root of 30 and divide by the square root of 30. So this is 30. This is 90. So this is 3, the square root of 30. Because when we multiply these two, we get 30. 90 over 30 is 3. So 3, the square root of 30 inches. So the width of the poster is 2 the square root of 30. The height of the poster is 3 the square root of 30 inches. However, I did not prove that this gives a maximum printed area. Now is the time. So let's look at x, a prime, and a of x. I think I should get rid of this one. And we have 2 the square root of 30, and we have 0. We go back to, where is my a prime? And I hope you agree we're not going to plug anything in here. So if this is 2 the square root of 30, let's plug in 0. When you plug in 0, what sign do we get? Very good. So now let's plug in 100 or 1,000. 1,000. 1,000 squared times -3 will definitely cover 360, and it will definitely be negative. So this is a typical situation for a maximum. Are we asked to find the maximum? What dimensions will give the largest printed area? So 2 the square root of 30 by 3 the square root of 30 inches will give the maximum printed area. If we want to determine the printed area, we can. Here it is. 186 minus 3 times 2, what was it? 2 the square root of 30. Minus 2y minus 2 times 3 the square root of 30. So this is 186. So this is max area. 186 minus 6 is minus 12 the square root of 30, and we can even approximate it if we wanted to see what the maximum printed area. So 186 minus 12 the square root of 30. Correct me if I'm wrong, I got 120 squared inches. Any questions?
So 120 is the max.
Roughly 120, I got 120.27, yes.